Yes, sir. Are.
Okay. So we're starting now. Today we're going to end this chapter. Now we have a emitter follower configuration. Okay. So emitter follower configuration means you have V input. Now this time I am taking output at the collector. Okay, this is the major difference between the circuit what we have done earlier. Okay, so this will change our calculation little bit. Now this is my original circuit. Okay, this is V input and V output I'm measuring here. So for AC analysis, okay, the first thing is to make the power supply grounded. Okay, once I make this ground, for AC this will become short, these become short. Okay, and if I say in the beginning that I naught current is flowing here. Okay, now I need to make equivalent circuit for this circuit. Okay, so obviously this will become ground. So you have V input and you have V, RB will be ground. RB will be grounded. Okay, and then I want to replace this junction by resistance beta RE. Okay, so this will be replaced by resistance called beta RE. Beta small RE. Plus now we have resistance RE also here. And this RE is grounded. Okay. Now this capacitor, this collector also, this is collector. Okay, this ammeter. Collector also become grounded. Okay. And after making this grounded, this is your beta RB. Okay. And this beta RB here, and collector I have to also add here. So this circuit will become now beta RE, and this will become your source beta AB, and this is your grounded. So basically this is now become your emitter terminal. Okay. So this is the equivalent circuit. Please check it. Tell me whether it's correct or wrong. Equivalent circuit. We are replacing this circuit. Okay. This collector circuit by this circuit. Okay. So this become ground. So this become ground. And this is by RB become short. This is your beta RE, and this becomes short. And I'm connecting like this. Okay. This is my equivalent circuit, beta RE. Now I need to find out ZI, Z0, AB, and AC. Okay. So this is your RE. Okay. So let me calculate now first. This is V input and V output. Now I'm taking here. This is my V output. This is V output. So why this circuit is called emitter follower configuration? So for you just look at here, you're applying V input here, okay, and V input will be consumed, okay, into resistance. One is this one, and one is this one, okay, and across this voltage, what you're taking, that is your basically V naught. So the if you apply voltage division, the almost all the input, okay, maximum this V input will be will be available here. Okay, and here consumption will be very less. Okay, it will be very consume very less. Okay, so this is your V input is equal to V output. In this particular type of circuit, your V input is almost equal to V output, so you'll get gain equals to almost equal to 1. Okay, that's why it is called ammeter follower configuration. Okay, so ammeter will follow the input, and the voltage and output and input voltage will be also in phase. Okay, so you'll see that now. First thing is I need to calculate my Z impedance for this circuit. So call it, this circuit is like, this is ZB. Okay, so I can call this resistance combined as a ZB. So Z impedance will be simply my RB and ZB, this particular case, isn't it? Okay, and here I'm calling this current as I naught, and if I say current, ammeter current IE also flowing here. Okay, so this is my Z impedance. Now if I want to calculate V input, okay, so V input will be what? V input will be simply, if I want this V input, so V input is your, or IB. So here current is following IB inside this one, this current is flowing IB. Okay, so if I make this IB, this I have to make beta RE, beta plus 1 RE, beta plus 1 RE, like we have done yesterday. Okay, so your ZB is basically beta RE and beta plus 1 RE. Okay, and IB, the base current IB value will be voltage, which is equal to V input here, that is V input here, and divided by this resistance, this is total resistance ZB. Okay, so V input ZB value is beta RE and beta plus 1 RE. Okay, so this is your IB value. Now I want to calculate IE value. What is IE value? So IE is simply beta plus 1 IB. Okay, so if I calculate IE, IE is beta plus 1 IB. Okay, so this become my beta plus 1, okay, VI upon beta RE plus beta plus 1 RE. Okay, now this will simplify my circuit. So now we have this beta plus 1, beta is greater than 1, beta is greater than 1, so I can write this as a simply beta VI, V input. Okay, and this is also beta RE, so this become beta common and this become RE plus RE. Beta beta cancel, so I have this VI RE plus RE. Okay, so now I have a simple circuit, simple equation. IE is nothing that is equals to VI upon RE plus RE. Okay, so I can draw this equation. Okay, I can simply so here what I'm writing here, I'm writing IB. Now if I write instead of IB, I write IE. If IE current flowing here, then this will be simply RE and this will simple also RE. Okay, but the meaning of this one is, if I convert this IB into IE, instead of IB, I'm writing the current in terms of IE. So then this beta will be removed, this beta will be removed. So I will be having simple circuit. So this simple circuit is you have V input here. Okay, you are applying V input, you have circuit RE. Okay, and then you have a circuit resistance RE. Okay, this is your circuit, and here you are taking V output. Basically you want to calculate V output here. So this is your V output here. Okay, now from this I can easily find out what is my V output. So V output is simply in terms of V input, okay, is equals to RE upon RE plus RE. Okay. Now from here you can see that gain V input upon V input, the gain AV is nothing, that is simply equals to RE upon RE plus RE. Now if this RE is greater than RE, okay, in that case your gain AV is almost equals to 1. That's why it is called voltage follower circuit. Okay, this is the expression for gain and this is approximation. Okay, so you have now voltage gain, you want to find current gain. Okay, so current gain here, so current gain is nothing, I naught minus I input. Okay, I naught, you know, here V is equals to minus IE. Okay, and I want to find what is I input. Okay, so calculate now what will be your gain, gain particular for this one. So I can write my I naught is minus IE, that is beta plus 1 IB. Okay, and I like we are earlier doing, if this current is I naught, I can always write IB in terms of I naught. Okay, so my from volt current division, I'm applying current division. Okay, I can write my I input is ZB plus RB upon RB into IB. Okay, and now you can find the current gain IE. Okay, beta plus 1 IB, beta plus 1 IB upon ZB plus RB upon RB into IB cancel. Okay, so this will give me beta plus 1 RB ZB plus RB. Okay, so this is the formula for minus also is there, minus also is there because IE I naught equals to minus IE. Okay, minus beta plus 1 IB. So this is your gain formula. तो अभी तो जितने भी कर रहे हैं मेथड सब में सेम ही है, थोड़ा बहुत वेरिएशन आएगा. So your exam only they ask a simple questions, whatever there's no limit of circuits. Okay, there are many circuits but the method is same. Okay, and generally the questions come very simple. Now let me do one more circuit which is slightly different than what we are doing so far. Okay, so this is like a we are doing are you getting this one na? We itne question kar liye, we have done at least 5 to 6 circuits. Okay, then you should have idea about how we are doing. Okay, so Z naught you calculate, Z naught is like same what we're doing. Okay, Z naught you can also find. So this will be now, this is slightly complicated. What we are doing so far, it was very easy. This is a little bit complicated. Collector, feedback, okay, feedback configuration. So this all circuit I am doing from Ball State book. Okay, so please look, that book is available in Drive soft copy. Please look that book. Okay, so now collector feedback means you have feedback from collector. Okay, I am directly making this as a ground. You have here RC, and from RC some feedback coming RF, and this RF is connected to here. You have V input here. You are applying plus BCC. Okay, and here you have capacitor V naught. This is C2. This is C1. Okay, this is your base, ammeter, and this is your collector. Okay, now tell me AC analysis. Okay, AC analysis. Okay, now this case AC analysis, this will be shorts. This will be short capacitor. This will be grounded. Okay, voltage again I'm taking here. So now how will do this one? This circuit, how will you make? Okay, this time this RF is not, RF is connected to RC, it's not getting ground. Okay, so only RC is ground. So you have V input here. V input is there, that is connected to terminal B. See, this is terminal B, and then B you have, this is your beta RE. Okay, and B to C RF is there. So you have B, and then you have RF, and this is your collector. Okay, now out of after collector you have always like your circuit beta IB. Okay, and then you have of course RC also. This RC is grounded, connected to collector. Okay, so this is B, this is C, this RC is connected to R, and there can be R0 also. I'm putting here R0. This is your RC. Okay, and if I say current is coming I0 here, so this I0 current flow again from here. Okay, and V0 I'm taking across C and ground. This is C and ground, and I'm taking V0 here. Okay, now here this resistance is there. Okay, so this will create problem in calculating the parameters. Okay, so this ये clear है, इसमें कोई doubt है क्या बनाने में? See, I how we made this V input B. Okay, between B and C, this there. After C you replace always is a current source grounded. This is a beta RE. Okay, this RC is grounded. This is the circuit is correct. Now just we need to calculate our, now here see I0 current is coming, and this current is beta IB current is going here. Okay, but some current is coming here also. If you see the circuit here, we having RC. Okay, I0 current was coming, and this current was going into the here, and the feedback also there, and this is making again base current. So this some current is going from I0, he's going here also. It's a negligible current, but still I say let this current is I dash, and here say the V source input is giving me I input current. Okay, and here we know always the current which flows here is IB. So I now the current I have represented. You can now solve for this one. This time RE was not there. Okay, so we don't require IE. Now you want V input. So V input is simply IB beta RE. Okay, V input is your, so V input is your IB beta RE. Okay, now of course IB is sum of I dash. Okay, so remember V input is IB is sum of I plus I dash. Okay, beta RE. And if I want V naught, so V naught is simply minus iota minus IRC. Okay, I naught RC. And if I say this I dash is less than beta IB, okay, then I can say my V naught is simply minus beta IB RC. Okay, so I have V input in terms of IB, I have V naught also in terms of IB, so I can find now gain directly from here. Okay, so I'm calculating first gain. So V output,
Sir, I not RC, how we write that I not beta IB?
ये जो करंट आ रहा है, यही तो IC तो बन रहा है सर्किट में, जैसे हमारा सर्किट आता है करंट I नॉट आ रहा था. ओके, this current is going here ना IC. IC, so IC is your beta IB ना, and I'm
Yes, sir.
saying this current is negligible.
Okay, sir.
Okay.
Okay.
Okay, so now I have V output. V input will be what? Simply minus beta IB RC, and this is IB beta RE. So beta cancel, IB cancel. So your gain is simple expression minus RC upon RE. Okay, this simple expression. Now here you have to also remember, you can write V naught also in terms of V input. Okay, that you have to remember, we use later. So my V output is in terms of V input, that is minus RC upon RE in terms of V input. Okay. Now we can find current. हाँ बोलिए.
Sir, here ZI.
हाँ ZI अभी करेंगे कैलकुलेट, ZI करेंगे कैलकुलेट. ZI थोड़ा इसमें थोड़ा डिफरेंट वे है ना कैलकुलेट करने का, बिकॉज ZI इज VI upon II. Okay, that we have to calculate now. Okay, so this is your AV. Now let me calculate your current gain. Okay, first current. So if I see this circuit, so if I take this circuit, whole circuit, this one. Okay, so if I call this current is coming here, say this is plus minus VF. If this drop is VF. Okay, and this is your V input here. This is your V input here. So I take this V input VF. I'm taking this loop. So I can write minus V input. Okay, this plus minus. So minus V input plus VF. Okay, and this is plus V input equals to 0. Can I write like this? In this loop, I'm going here to directly here. So here I have V input. Okay, here loss is VF, and this is this one, V not this one. Okay, now I know what is my V input. V input in terms of IB beta RE. Okay, V naught is what? V naught, I just now write minus I naught RC. Okay, so V naught is just what? Minus I naught RC. VF is what? VF is your I dash RF. I dash RF. Okay, and V input V input is your simply IB beta RE, IB beta RE. Okay. And just now I told you I naught is also equals to IB. So I can write beta IB RC I dash. So I dash is what? So these two current I dash and I dash making IB. So I dash is simply IB minus I input RF plus IB beta RE equals to 0. Okay. Now I want IB value in terms of IB value in terms of I input. Okay. So IB will be what? IB will be, I'm taking IB that side. What should I do? IB. Okay. So IB is what? RF. IB is RF. IB RF plus beta RE. Okay. And plus beta minus beta RC. This is IB, and that is equals to minus this become IIRF. Okay. Just I'm putting this value. I'm doing a little bit algebra. Okay. So this is IIRF. Okay. Well, let me check whether I'm doing correct or not. So sign, just check sign what mistake happened. Yeah, I minus one.
V naught वाला part.
हाँ
सर जो V naught हमने लिखा था
हाँ
वो माइनस V naught तो पहले लिख दे रहे हैं, तो वो प्लस हो जाएगा ना, बीटा
हाँ
आई.
हाँ हाँ प्लस प्लस कर दिया मैंने, प्लस कर दिया सही, माइनस पहले दिया हमने I dash what is writing I dash RF, I dash I input RF. Okay. Now from here I can find the I input value. So I input value is nothing, your RF plus beta RE plus beta RC, okay, upon RF into IB. And I naught already I know, I naught is what? I naught is simply minus beta IB. So you can get the gain. So gain will be minus IB will be cancelled. So minus beta RF, okay, RF plus beta RE plus RC. This should come the gain. ठीक है, RF plus beta RE. ठीक है. This is my gain formula. It is simple. मैंने second लगा दिया. We use some simple KVL here, okay. And calculating gain is simple. You know, we input this one, we output this one. You have got the voltage gain. Applying this current and this KVL in the in this path, in this closed path, we got AI. Now calculating ZI, that is a little bit trick, okay. So I want to calculate ZI, okay. So ZI is nothing. ZI is your V input, I input, okay. So that we need to calculate. Now I told you in the beginning, okay, if you want ZI, okay, your VI is II plus I dash beta RE upon I input, okay. So you need to first find this, what is the value of this I dash, okay. Once you know the value of I dash, you can put here and you can calculate this your you can bring I in terms of this input current, and then you can calculate ZI, okay. So what is I dash basically, okay. So if you see this circuit here, at the C my voltage is V naught and at the B my voltage is V input. Okay, and V output my minus V input. V input minus V input upon RF is my I dash. Okay, so this is my V input, V naught, this is my V input, and the difference of these two nodes, okay, will you give the current I dash. Okay, now I already know V naught, so this will be what? V naught upon RF minus V input upon RF. Okay, and V naught value I already know in terms of V input, so I can put this value here. So this will be V naught value will be minus RC upon RE V input, and this is minus VI upon RF. Okay, and if I take V minus common, so this become 1 upon RF plus RC upon RE V input. So this is my I dash value. Okay, now this I dash value I need to plug there. So plug this. So V input, okay, I have I input beta RE, and then I have a I dash beta RE. Okay, so I beta RE plus I dash value is this one. Okay, I dash value is minus 1 upon RF plus RC upon RE. Okay, V input beta RE. V input beta RE. Now V input term you can take there, so you can find now ratio of V input upon I input. Okay, so you want basically V input upon I input, na? So here is V input, here is V input, to take common V input. Okay, so V input will be what? V input will be, this is 1, and this will be simply 1 upon RF plus RC RE. Okay, and multiplication beta RE. Okay, equals to what? Equals to I beta RE, I input beta RE. Okay, now you can calculate V by I. So this will give you Z value.
Sir, this RF was along with both V naught और VI दोनों टर्म्स के साथ था ना? V naught upon RF minus VI upon RF था.
कहाँ पे?
सर जो सारा वो आपने मिटा दिया.
भी हमने क्या लिखा?
तो यहाँ पे ये जो आपने आप यहाँ पे नीचे
यहाँ
लिखा
ये प्लग किया ना?
सर, ये नीचे सर राइट साइड देखो सर,
ये
राइट. सर जिस टर्म के आप आगे खड़े हो,
ये वाला ना, ये वाला.
नो सर, यस सर, ये वाली टर्म है, लेकिन वहां पे ना
हाँ,
सर, यहाँ पे जब आपने पुट किया था, जो आप सर आपकी
पूरा
तरफ है
पुट किया था मैंने, ये वैल्यू तो पुट की थी मैंने.
सर, ये
मैंने आई डैश के लिए पुट की थी ना.
सर आपने जब वी नॉट वी एफ निकाला था हमने,
हाँ
वी एफ वो था वी नॉट माइनस वी आई अपॉन आर एफ, जो आई डैश निकाला
हाँ
था.
हाँ, ये वाला.
यस सर.
हाँ, तो
सर यहाँ पे आर एफ कॉमन आएगा ना?
कहाँ पे आ रहा है, कौन आएगा? जस्ट वेट मी चेक करना था मुझे. 1 प्लस बीटा आर ई आर एफ 1 प्लस आर सी.
सर आई डैश वाज वी एफ अपॉन आर एफ एंड वी एफ वाज वी नॉट माइनस वी आई.
Sir, in the right side of the board, down.
सर जिस टर्म
Last
सर
line.
आप सामने
ये यहाँ पे सही लिखा हुआ है कि यहाँ पे सही लिखा हुआ है?
सर राइट साइड पे आप सर्किट के नीचे जो इक्वेशन लिखी है ना आपने.
हाँ, ये वाला. अच्छा,
हाँ जी सर. सर ये वी नॉट अपॉन आर एफ भी था ना?
हाँ, तो वी नॉट वी इनपुट कॉमन निकाल लिया ना मैंने.
सर आर एफ भी कॉमन ही आएगा ना?
आर एफ कॉमन क्यों लूं मैं?
सर आप लिखा नहीं ना यहाँ पे हमने आर एफ.
तो
वी
1
नॉट
वन प्लस आर एफ लिखा है मैंने, इसकी जगह 1 प्लस आर एफ लिखा है, 1 प्लस आर एफ लिखा है. यहाँ पे मैंने आरसी बाय आर ई लिखा है.
सर इट वाज वी एफ ना? दिस इक्वेशन वाज फॉर वी एफ ना?
लेट मी डू इट अगेन. ओके, जस्ट मुझे वापस करने दो. क्या जब बोला अब बताना क्या कर रहे हैं, ठीक है. Just give me 1 minute, okay? So what we are doing, okay? We were calculating this I dash first, okay? So this I dash was what? Your V naught minus V input upon RF.
Yes,
ये
sir.
करेक्ट है?
This I was
हाँ,
saying
अच्छा.
that this
हाँ,
RF was
हाँ, अभी चेक करते हैं ना. सो मैंने इसको लिख दिया V naught upon RF, okay? V input upon RF, okay? Now V naught is your, हाँ, you saying correctly, minus RC RF upon RE, okay? V input minus V input upon RF, correct. Okay, thank you. So now minus 1 upon RF common, okay? V input is common. Then you will have what? RC upon RE plus 1. अब ठीक है?
yes, sir.
Okay. So now put this value here. Plug this I dash value here. So you have V input, okay? So you have I input beta RE plus I dash is your minus V input RF, okay? RC plus RE, RC plus RE plus 1 beta RE, okay? And this will give me V input 1 plus 1 upon RF, RC plus RE plus 1, okay, beta RE, and this is your I beta RE, okay. And final, I'm erasing this one, okay. So this will give you what? ZI equals to VI upon II, okay. That is beta RE upon 1 plus 1 upon RF, RC RE plus 1, okay. Now let me check the expression. This is my beta RE, okay, 1 plus beta RE upon beta. Here beta RE is there somewhere. Did we mistake anywhere? Beta RE should come there.
और ये आ तो रहा है,
हाँ
मतलब
हाँ, आ रहा है, ये तो आ रहा है.
ये
हाँ ठीक है, बस ठीक है फिर. So beta RE 1 plus beta RE RF upon 1 plus RC upon RE. Correct equation, okay? It's correct. Now they can simplify it further, okay? पर हमको simplify करने की जरूरत नहीं है. So I think now we have completed this part, okay? Now the remaining is Z0, okay? So Z0 I'm giving you homework, okay? Z0 is yours. Z0 will come your RF parallel RC, okay? That is your homework. So you have this resistance, okay. This is your V0 C, RC RF2, okay, C3, this is grounded, the capacitor, RF1, okay, and this is connected to here. Okay, so you just need to tell me in this particular case, okay, I'm not asking to solve you just tell me if I'm taking V0 here, okay, what is the Z impedance, Z input and Z output in particular this particular circuit. Okay, just tell me the values. R0 take infinite, or you can put R0 use output impedance, you can add one R0 also. Now just tell me what is Z0 and Z0, okay. You tell me right now, and AV and AI is your homework. बताओ कितना आएगा? Just carefully look कि rearrangement कैसा होगा when you do this one equivalent circuit, that time how will you do the arrangement. So for AC part, what you'll do, you'll make this one grounded, okay, इसको ground करोगे, ये short हो जाएगा AC के लिए, this become grounded, this short हो गया, this becomes short, okay. Now you make short this one. Now just to see the resistance, this RF1 is connected to base and ground, so obviously this will be input kept input. This RF2 is connected to ground plus collector, so this will go to output. Similarly, RC will also go to output, okay. So if I make this circuit equivalent circuit, that will be your V0, okay. Here RF1 will come in input, okay. Then you have beta Re, this resistance, this part, okay. This is your beta Re, okay. And then you have a, so this is your base, okay. This is a base part. Say this point is B, this point is B, both point is B, okay. Now collector is nothing is common here. R is not common, so you can separate out collector. So collector will be like this, beta IB, okay. And this time RC RF also will go, okay. If you put one R0 here, okay, so RC also will come here, and your RF2 will also come here, okay. So if you want to calculate, say this is I input, I0 is coming here, so I0 is coming here. So this particular question, your Z impedance will be simply combination of RF1 parallel to beta Re, and the Z0 will be combination of R0 parallel RC parallel RF2, okay. Now you need to calculate voltage gain, current gain, taking R0 as infinite. ये होमवर्क आपका. Okay, so ये finished हो गया, analog आपका finished हो गया है, okay. Now just we need to finish digital, and digital will settle 6 to 7 classes more, then your course is complete. So we'll meet after 5 minutes, 7 o'clock for digital. Thank you.
Thank you, sir.